Welcome to Study Loop.
So here the question says that there is an electron which has a velocity v given as 32I plus 40J, and they are in kilometer per second. So the velocity has components in x and y direction, and it enters a uniform magnetic field B, which has a magnitude of 60 microtesla. Right? So if I want to convert this, we can do it later. So what is the radius of the helical path? So this r equals to what? What is the radius r? Right? R equal to what? And the second question is, what is the pitch? So pitch is the distance between two circles, right? In this spherical motion, in this helical motion. Okay, so what is d? The pitch. So let us start. Now, since the magnetic field B is along x direction and velocity is along x and y both directions, so since we have the expression for force says that F is equal to Q times V cross B, right? Now, if V and B have the same direction, there is no force. So if you look at this case here, so there is no force along x direction, because B is also in x direction. In x direction, velocity will not be experiencing any acceleration, right? And similarly, the velocity along J is perpendicular to B, right? Because B is in I direction, so there it will experience maximum force, right? So the electron is going circle, right? The circular motion of electron is due to the force due to magnetic field, and the forward motion along x-axis is due to the constant velocity, that is 32 I hat. So if we want to calculate the radius, so we have to use the velocity along y-axis, right? So first calculate the radius here. So to calculate radius, we need to consider the velocity along y, because that is the velocity that experiences the force. So mvy squared by r, that is the centrifugal force, which balances the magnetic force, that is equal to B is what? B into Q times V, right? So sine 90 gives you 1. We don't need to write arrow here now. And this is Vy. So cancel out square and Vy here. So this gives me R is equal to M into Vy upon Bq. So we know what is M. So we know that mass of electron M is equal to 9.1 into 10 to the power minus 31. We know Vy is equal to 40 kilometers per second, so that is 40 into 10 to the power 3 meters per second, and B is equal to magnitude of B is 60 microtesla, so that is 60 into 10 to the power minus 6 tesla, and you know that Q is equal to the charge of an electron, that is equal to 1.6 into 10 to the power minus 19 coulomb. So plug these four values in here, then you get R equals to 3.79 into 10 to the power minus 3 meters. Okay. So we are done with part A of the question here. So let's move on to part B. So in part B we have to find out the pitch. So B here. To find the pitch, we need to consider the velocity along x, right? The velocity along x. So this distance here d, now the velocity along x remains constant because there is no force acting on it. So velocity remains always 32 km per second along x. Now what is the time taken by the electron from this point to this point? What is the time? So if you look from along x-axis, then that will be a complete circle. When electron from here reaches here, that can be considered as one complete circle. And for one complete circle, uh, the time taken is what? The time period, right? We can just easily find that out. So distance d is equal to velocity along x-axis into time period. Now time period is again dependent upon the velocity along y. So time period is equal to 2 pi r times vy. This is multiplication, okay? Right. Now if you multiply this here, given that vx, velocity along x, is 32 into 10 to the power 3 meters per second. And you know r from part A of the question, you know vy. So this will give me d equals to 0.019 meters. All right. So this ends the part B of the question. Now let's move on to part C. Okay, what is in the C? Okay, to an observer looking into the magnetic field. Okay, an observer is looking from this point, right, from the entrance of electron. So what will the observer see? Is the electron moving clockwise or anti-clockwise? Now let us consider uh, any point in x direction. All right, so at this point, suppose here at this point, let us consider the velocity is along this. Okay, right. Now what is b? B is along x-axis. Now if you use the right hand rule, then the force will be oriented towards the center, right? Then the force will be oriented towards the center. So if the person, you have to imagine this, okay? So if the person sees this electron, then it will see the electron just revolves like this, isn't it? The electron just revolves like this. So it is clockwise just by using right hand rule. Okay. So this ends the solution for this question. Thank you for watching.